Finally, there's a bit of integration here with Selinux and IPA, so you can pull in things like user contexts from IPA quite easily. You can also integrate with LDAP to a small extent. We'll touch on that. So we're going to finish off talking about the alert system, SE troubleshoot D, and talk about how the relationship between Selinux and intrusion detection systems. So discretionary access control versus mandatory access control. Discretionary access control, DAC, is the access control you see in Unix systems for 30 years. So file permissions, things like your CH0, 755, 644, these sort of things. These are file permissions in all Unix systems, but they are discretionary access control. Okay. And what this means is that by default, users, processes, that sort of thing, have full access to the system unless there's a permission in place that specifically denies that access. So things like your shadow file have a permission set in it specifically by your distribution designer or RHEL or Debian or whatever you're using. Will set the permission for you by default, and you probably accept it as defaults. If those permissions are not in place, then you can go through and read any file on the file system and sort of do anything you like. So mandatory access control, or Selinux, is an implementation of mandatory access control, changes that concept and says by default you have no permissions on the system whatsoever. So Selinux starts off with no permissions and then specifically allows the permissions that you need in order to run your process, to run as an administrator or something like that. Okay? So it's sort of a whitelist. Blacklist versus whitelist. So how is mandatory access control, how is Selinux going to be useful in the enterprise, and how is it implemented? It's implemented on top of discretionary access controls. It's not going to get rid of file permissions, but actually Selinux adds a label to different types of objects. So your file system objects, for example, will now have an Selinux label. You've probably seen this already. If you do LH with a capital Z, then you'll see actually you've got your normal file name, your date times, all that kind of stuff, but you also have Selinux context. Use the -Z argument. You may not be familiar that Selinux actually can cover processes. So if you do PS with a capital Z, you'll see processes have their own context as well as users. So ID with a capital Z, again, same argument for all these sort of things. Users have their own context also. One of the less known things about Selinux is it actually can cover network ports as well. It's complementary to your firewall. It's not replacing your firewall, but ports also have Selinux context as well. Okay. So you can see that Selinux actually extends discretionary access control more than just file system permissions and covers the file system itself, but also processes, users, and network ports also. Selinux is implemented in the Linux kernel, so all the permission checking is kernel side or kernel mode. There's no user space process to kill. You can't sort of get rid of Selinux that easily. Okay. So how does the Selinux implementation work in RHEL? Well, Selinux requires a policy in order to work, but Selinux can be in one of three states. So disabled, I'm sure there may be a few snickers, people probably disabling Selinux on their production systems. Obviously, so it can be disabled, but Selinux, the opposite, can be in enforcing mode. In enforcing mode, Selinux logs all accesses that sort of affect rules and policies that are denied and accepted. There's a mode in between. There is the permissive mode, which does logging but doesn't enforce security checks, doesn't deny anything. Now, permissive can be really useful for debugging and for logging. If you're setting up a new application or a new service, trying out a new configuration, then permissive mode is especially useful. Okay. By default in RHEL, it's enforcing by default. Now, Selinux was a new technology around about the RHEL 4 days. And Selinux has been since RHEL 4, and it kind of sucked. There was a few things that were broken in RHEL 4, and you get alerts pop up and think, okay, what's this? It's probably not so fine-tuned, but as with any new technology, it's sort of gone through its maturing phase. In RHEL 5, Selinux shouldn't cause too many problems. You'll still get a few things pop up, I'm sure, but the Selinux policy was vastly improved in RHEL 5. Nowadays, the Selinux policy in RHEL 6, I think, is pretty well fine-tuned. It shouldn't really come up and pop up with any alerts or any unexpected log messages. It's pretty stable in RHEL 6. Obviously, it's going to be around in RHEL 7 also. And we've done a bunch of improvements to Selinux again in RHEL 7. We'll touch on a few of those in this presentation. So coming back to the policies, SE-Linux requires a policy in order to work. A policy is a set of rules, like a set of firewall rules, for example. And the policy that comes with Red Hat is the targeted policy, written by Red Hat, which tracks the upstream project. The targeted policy has rules in there for things like HTTPD, like your MySQLD, SNMPD, all this kind of stuff. All the common daemons that people will be running on their systems have SE-Linux policy rules in there in place working. This means that HTTPD, your web server, is going to work out of the box with SE-Linux, with a default configuration. Okay. The targeted policy has been, again, improved in RHEL 5 and RHEL 6. There's another policy set available called MLS. Now, I don't know how many people are familiar with multi-level security, multi-category security. A really interesting technology, and actually I could spend another 40 minutes talking about that. Unfortunately, as awesome as the technology is, it's for many a pretty small audience, and we're not going to go into MLS and MCS today. Any questions after the session? Happy to talk about that. MLS and MCS, the two other policies available, or the other policy available, is mainly used by organizations that require high levels of security, like your three-letter agencies, like your NSAs of the world, but also is now seeing use in financial institutions, in government and military. Okay. So I've got a little icon in the bottom right-hand corner of the slide, which means raise your hand. So who here likes SE-Linux? Okay, cool. Nice to see a few hands. Who runs SE-Linux Session Force 1, enabled by default still? Not so many hands. Okay, cool. Never mind. So how do we make SE-Linux work with our existing service configurations? How do we make SE-Linux work and actually use the security that SE-Linux provides and not just disable the thing? How do we stop SE-Linux breaking my app? Yeah, we've just got a new application from the developer team, install the thing on your server, and SE-Linux stops it from working. Won't let it access directories, access files, that sort of thing. These things happen, but it's not SE-Linux at fault, it's sort of your fault. And I'm going to explain about that a little bit later. So, how do we run SE-Linux with Session Force 1? i.e., how do we run SE-Linux in enforcing mode and keep the thing in enforcing mode? So let's cover some of the common problems that we see with SE-Linux. Okay.